Alright everybody, welcome to the 8K notes on segments and circles. We're going to start off this section of notes doing what we've done in every section, and that is defining and drawing a picture of tangent, chord, and secant. It's important that we know these vocab words and know the differences between them because they're used in the directions or they're used in information in the problem. So if we say, find the secant or find the length of this chord or use the tangent and you don't know what those things are, then that's bad. Okay? So let's do that. Let's define tangent and draw a picture. The first, tangent is a line that intersects the circle at one point. So I got that. I got a circle there with just trying to make it look like there's one intersection. A chord is a segment whose endpoints are on the circle. A diameter is an example of a chord, but not all chords are diameters, right? So there's that fact. A secant is a line that intersects the circle at 2 points. Okay, so it cuts through it all the way through. So there's that. Let's take a look at the intersecting chords theorem. Okay, we have an interior segment formed by two intersecting chords. And what this tells us is that the theorem is basically this. It's the product of the pieces equals the product of the pieces. Okay? Product means multiply. Pieces are the separate parts of each chord. So in this example circle, what you see is that we have A times B. So this segment that we're labeling as A, so let me show you. This segment right here times this segment right here, B, is equal to, their product is equal to this segment D, and then this segment, let's do a different color blue, then this segment right here, C. So their products are equal. So now what we can do because of that is we can take a problem, for example, like this you have on the next page, and we can say that the product of the pieces given intersecting chords are equivalent. So I'm going to set this up simply by saying 2 times x. That's a little too thin there for me. For my taste, 2x equals 8 times 2.5. 8 times 2 is 16.5. 8 is 4. 4 plus 16 is 20. You're all very impressed. So x equals 10. Let me just show you one other thing real quick, just so we have this set up so you can see all the different parts. The product of the pieces here, this is 8 times 2.5. Okay, that's what's going on over on the right side. Okay, and then that is equal to 2x. That's how we got our 20. Pretty simple. Product of the pieces equals the product of the pieces. Let's take a look. See, this is where the problems can get a little bit more complicated because we're asking you to find the radius. So we're going to use this product of the pieces idea and then use that in the end to find the length of the diameter and then use that to find the length of the radius. So here's what I mean by that. On this one right here, we have this is 6 and this is 6 and this is 3, and then this is the part we don't know. So I'm going to add a variable x for that. Okay? So then I'm going to do 3 times x equals 6 times 6. And we get 3x equals 36. And so x equals 12. But that doesn't answer the question. The question is, what is r? Okay? What is this right here, the radius? So if x is 12, then I know the diameter is 12 plus 3. Okay, so 12 plus 3, which is 15, which then makes the radius half of 15, so r is 7.5. Okay, let's try another one. Pay attention to this announcement. It's going to be really important. Ah, very good. Calling a random student to report to the office. All right, so here's this missing part here. That's x. So again, we have 6's, so we'll do 36, the product of 6 and 6, equals 10x. So x equals 3.6. And again, we added the x. You can use whatever variable you want. If x is 3.6, then the whole diameter is 3.6 plus 10, so that's 13.6, which makes the radius half of that. Half of 13.6 is, if you said 6.8, you are correct. Let's take a look at the next page. So we also have intersecting secants, okay? And the intersecting secants theorem says that this outside piece here, A, times the sum of the entire secant, okay, equals this outside piece here, C, times the sum of C and D, the entire secant. Or some people like to think of it as outside times the whole thing equals outside times the whole thing. Ow equals ow. So like if you hurt yourself, it equals you hurt yourself. I'm not sure that makes sense, but let's take a look at an example problem. So here we have a problem where we're solving for x. Okay, so let's set this up. Let's remember outside times whole equals outside times whole. And here's what that looks like in action, okay? We take the outside of this right here, so this AB part, okay? So AB is 4 times the whole thing. Well, the whole thing is 4 plus 6, so that's 10. And that's going to equal 2 times the whole thing here, and we got to be careful. This is not 2x, this is 2 plus x. So 2 plus 2 plus x. 2 times 2 plus x. Once you have it set up, it just becomes an algebra problem. Alright. You just have to work your way through. You end up with 2x equals 36. So x equals 18. Easy enough. Let's take a look at another one. Secant and tangent theorem. Okay, secant and tangent. I still think that this is kind of like outside times the whole thing equals outside times the whole thing. It just so happens that over here on this tangent, the outside and the whole thing are the same. So for example, this would be A times itself, outside whole thing, equals B times B plus C, which sometimes people will refer to as D. And so, you know, you can plug in D, but really, let's take a look at a problem, and this will make a little bit more sense here. So here we have, in the figure, if AD is 9, so this piece here is 9, and AC, the whole thing is 25, find X. So we'll say X is right here, okay? So we have this outside times the whole thing, so that's X squared, X times X, equals 9 times the whole thing. Well, in this case, the whole thing is 25. So 9 times 25 is 225. And the square root of 225 is 15. Easy enough. I will say that there are some examples, some problems on the homework that you're going to have to factor. If you need help factoring, there's lots of videos you can find on that. Check Khan Academy, check Purple Math, check all over the place. If I get enough requests online, I might put up a video just reminding us how to factor so that we can solve these problems. Good luck, have fun, stay on the sidewalks. The roads can be scary because a lot of you are starting to drive. See ya.
Everybody in the house make some noise!